Good morning, my dear friends. Myself, Dr. M.H. Annaya, and in this video, we are going to work out a problem on an eccentrically loaded riveted joint. Sorry, this is a welded joint, eccentrically loaded welded joint. And the question for today's video reads as under: for the eccentrically loaded, it should be welded joint. Welded joint shown in figure determine the size of weld required, taking the permissible shear stress as 80 Newton per millimeter square. Friends, you have a load of 20 kilonewton acting at a distance of this much, that is eccentricity equal to 300 plus this is 350 millimeter. And the calculation of the size of the weld involves, as usual, 5 steps. In the first step, we are going to locate the centroid of the weldment. In the second step, we calculate what is the direct load and where it acts. In the third step, we find out what is the secondary load and what is its orientation with respect to the point where it is acting. And in the fourth step, we find out the resultant of the direct and shear load. And finally, we equate the resultant load to the value of, that is the shear strength of the weldment, and find out the size of the weld. So friends, for this system, we will find out or locate what is center of gravity. Where does center of gravity lie? Friends, since this is symmetrical about both the horizontal and vertical axis, G lies here, and this is at a distance of 300 plus this is 50. 350 is the value of eccentricity, that is from the load axis to the center of gravity, it is 350 millimeter. So CG lies here and eccentricity is 350 meter. We call it as small e. Friends, in the second step, step number 2, we find out what is the direct load. This direct load, friends, is given by PD is equal to direct load, that is given by the total load acting divided by the total length of weld. I will write down the load acting, total load, that is P, divided by length of weld, this total length of weld. And this is total load is 20 kilonewton, 20 into 10 to the power of 3 Newton, divided by length of weld. This is D, we call D plus D. We will say this as D and this as B. So length of weld will be D plus D, that is 2D. So 20 into 10 to the power of 3 divided by 2 times D is that 50. That is equal to, if we simplify, it works out to 200 Newton and length is in millimeter. So this PD has a value of 200 Newton per millimeter, and we have to locate where does it act. Friends, here if you see the 4 corners ends of the weld like A, B, C and D, all these corners are the extreme ends of the weld are equidistant from G, that is this length equal to this, equal to this, equal to this. So when this is equidistant from all these, we can consider one of those points. Say this point is point B. I'll write down somewhere here. This is point A and this is B. So I will consider point B, and at this point B, I will show a load PD acting downward. So PD acts at the farthest end of the weld, and its value is equal to 200 Newton per millimeter. It will be acting parallel to the applied load, that is P, and in the direction of it. And hence, I have shown at this point the value of this PD, and that is parallel to P. So the second step is completed. In the third step, friends, we find out what is the secondary load and where does the secondary load act. I will say step number 3, to find out the secondary load. Secondary load. Friends, if you refer to the data handbook, the secondary load, I will call it as PS, whatever it may be. Secondary load is PS. So friends, if you refer to the machine design data handbook, there is a big tabular column for the location of the value of this weldment corresponding to the dimensions B and D. That is secondary load is given by the formula, that is secondary load is given by the formula D into 3B square plus D square, B multiplied by, sorry not B, this D, D multiplied by 3B square plus D square, 3B square plus D square divided by 6. And here friends, this value D is the depth, that is the length of weld in this case. This is 50 and B is 100. This is 50 multiplied by 3 times B square, 100 square plus D square is 50 square divided by 6. This is the value of the secondary load. Friends, now we have the formula to find out the value of this secondary load, and that is given by PER by J. P secondary is equal to PER by J. Friends, P is the total load acting, that is 20 kilonewton, 20 into 10 to the power of 3 Newton. E is the eccentricity, that is 350, 300 plus 50, that is 350 multiplied by R. The value of R is the distance of the farthest end of weld from here. So friends, this is R, all are equidistant. So friends, you can find out the value of this R, and this R is from this triangle, right angle triangle, this square, that is just R is equal to this square plus this square under root. So I will call this as R, the distance, that is 50 square plus 25 square under root of 50 square plus 25 square under root. That is the hypotenuse is this side, that is 50, and this is 25. So square divided by J. Friends, J is the polar moment of inertia of the weldment, and in the previous step I have shown this as D bracket 3B square plus D square divided by 6, and this value works out to a value equal to the value of this PER by J, PER by J value you can substitute and find out. And this works out to a value. So you can know the value because D is given as 50 and this 3 times B square 100 square plus D square 50 square divided by 6, you know the value. And friends, you know P, E, R and J. The value of this R here is equal to 55.9. So friends, you will be able to find out the value of PS, the secondary load acting at the point B because of eccentricity. So we have this value of PS. Friends, this PS will be acting at the point B normal to this R, means perpendicular to R, so as to produce a moment similar to the moment produced by P about G. In other words, about G, P is producing a clockwise moment. So also the secondary load acting here perpendicular to this R should produce a clockwise moment. So you can see here the moment of P is P into E acting in the clockwise direction. The moment of this is the secondary load PS into this distance acting in the clockwise direction. So friends, this is our PS, the secondary load. So we know direct load and we know the secondary load. And friends, in the next step, we are going to produce or find out what is the resultant of these two. So I will say step number 4 to find resultant, to find P resultant load. That is to say, that is resultant load PR. Friends, here you have the direct load, you have the secondary load which is acting perpendicular to here, and to find out the value of the resultant load, we have to complete this parallelogram, and the diagonal of this will give you the resultant load PR. PR is the resultant load, the secondary load is the direct load. And friends, we have the formula PR is equal to square root of P direct load, P secondary load plus 2 times PD PS into cos theta, where this theta is the angle between these two, that is PD and PS. That's the angle. So this angle is to be found out. This is the angle between them, that is, I will call it as theta. Friends, how to find out this theta? This theta, the angle between PD and PS will be lesser than 90. So if you are able to find out what is the value of this, that is say this angle beta, I will call this beta. So the total angle is 90 minus beta will give you the required angle theta, the angle between the direct load and the secondary load. Friends, if you can just see here, this angle beta is same as this angle beta. So this is beta. So observe carefully, this is the value of beta. How to find out this beta? We want cos theta in the formula. We can take it directly. So cos theta is equal to adjacent side. Suppose say this is K. Adjacent side divided by hypotenuse. So I will say cos theta from this triangle GKB. From triangle GKB is equal to this beta is adjacent side, that is 25 divided by the radius. Radius equal to r, that is 55.9 from calculation. And friends, you will be able to get this as 0.8945. 0.8945 is a value of cos theta from this triangle GKB, this right angle triangle. Friends, you have all the values here. So we know direct load, we know the secondary load, and we know this cos theta. And if you substitute the values and simplify, you will be able to get the value of this resultant load. And this resultant load is 1626.16. 1626.16 Newton per mm. This is the resultant of the direct load and the secondary load. Finally, friends, we will move on to the final step. That is the step number 5 to find out the size of the weld. Step number 5 to find size of weld. To find size of weld. Size of weld is small h. Friends, to find out this, we equate this shear stress tau to PR divided by 0.707 into h, where h is the size of the weld. Friend, the shear stress is given to be 80 Newton per mm square. I will make the substitution, and this PR, we have found out the value as 1626.26. 1626.26 divided by 0.707 into h is unknown. So friends, if you simplify, you will get the value of h as 28.75 mm, and we can round it off to h is equal to 29 millimeter. So this is the size of the weld required for this particular problem to sustain a load of 20 kilonewton at a distance of 350 millimeter from the centroid of the welding. Friends, I hope the presentation was interesting. Please go through the complete video without fail. And if you are not subscribed to my channel, please do it today without fail. And you convey this information or share the information about my channel and my videos to all your friends. Thank you very much for watching my YouTube video. Have a blessed day.